Now that we've looked at the dry bones of the vertebral column, let's look at the structures that hold the bones together and that enable them to move. We'll look first at the intervertebral discs, then at the ligaments of the vertebral column, then at the posterior joints. These structures are arranged in a similar way from the top of the spine to the bottom. We'll be looking at all of them in the lumbar region. Here's an intervertebral disc. The disc is a massive pad of fibrocartilage that's firmly attached to the vertebral body above and below, all the way around the circumference. If we cut through a disc and look at it from above, we see that it's made of concentric layers of material. The disc consists of an outer ring of tough fibrocartilage called the annulus fibrosus and a soft center of almost liquid material called the nucleus pulposus. The disc is solid enough to transmit the weight of the body, and it's flexible enough to permit movement between the vertebrae. The side of the intervertebral disc forms the anterior margin of the intervertebral foramen, through which the spinal nerve emerges. The vertebrae are also held together by ligaments. Some of these go from vertebra to vertebra, some run the length of the spine. Starting at the back, we'll look at the ligaments which hold the spinous processes together, the interspinous and supraspinous ligaments. Then we'll look at the ligament that holds the laminae together, the ligamentum flavum. Then we'll look at the two ligaments which help to hold the bodies together, the anterior and posterior longitudinal ligaments. First, the interspinous ligaments. Here they are. They run from the lower edge of one spinous process to the upper edge of the next one. Now we'll add the supraspinous ligament to the picture. The supraspinous ligament merges with the interspinous ligaments. It runs the whole length of the vertebral column, connecting the tips of the spinous processes. The supraspinous ligament serves as a midline attachment for some important muscles, as we'll see later. These ligaments help to limit flexion of the spine. The structure, or structures that chiefly limit flexion of the vertebral column, is the series of short ligaments that hold the laminae together, which are known collectively as the ligamentum flavum. The ligamentum flavum lies on the front of the laminae. To see it, we'll cut through the pedicles of all the vertebrae along this line and look at the laminae from the inside. Here's the ligamentum flavum. It goes from one lamina to the next, all the way down the spine. Here, where it's been cut through, we can see how thick it is. The ligamentum flavum is made of yellowish fibroelastic tissue, hence its name, which means yellow ligament. Next we'll look at the two ligaments which hold the vertebral bodies together, the anterior and posterior longitudinal ligaments. The anterior is the stronger of the two. Here it is. The anterior longitudinal ligament covers the front and sides of the vertebral bodies. It runs the whole length of the vertebral column. We'll cut through it along this line to see it better. The anterior longitudinal ligament is thick and strong. It's attached to the upper and lower edges of each vertebral body. It limits extension of the spine. In extension, the tightness of the anterior longitudinal ligament helps to prevent backward and forward movement of the vertebral bodies relative to each other. The posterior longitudinal ligament runs along the back of the vertebral bodies. To see it, we'll divide the pedicles along this line again and look at the bodies by themselves. Here's the posterior longitudinal ligament. It's narrow where it overlies each body, and it widens out to cover the back of each disc. The posterior longitudinal ligament helps in a small way to limit flexion of the vertebral column. Each vertebra is attached to its neighbors not only by the intervertebral discs and the ligaments that we've seen, but also by the joints between the articular processes, the posterior joints. Each posterior joint is surrounded by a capsular ligament, which is loose enough to permit the small amount of movement that occurs between any two vertebrae. The capsular ligament has no great strength, but the articular processes themselves are strong. Because the upper ones face forward and the lower ones backward, the articular processes prevent the vertebra above from slipping forward relative to the vertebra below. Now we'll look at the muscles. Most movements of the vertebral column are produced by an extensive set of muscles that run all the way along the back of the spine. They're known collectively as the paravertebral muscles. The highest of them are attached to the base of the skull. The lowest ones arise from the sacrum and iliac crest. Some in between are attached to the backs of the ribs, and many are attached to the transverse and spinous processes of the vertebrae. We'll build up our picture of these muscles from the inside to the outside. This is a dissection of the mid-thoracic region. On the left side, all the paravertebral muscles are in place, partly hidden beneath a covering layer of fascia. On the right side, all the paravertebral muscles have been removed. We're not concerned at present with these outlying muscles, the levators and the intercostals. Now we'll add the paravertebral muscles to the picture, starting with the ones that lie deepest, the short and long rotator muscles. Each short rotator goes from a transverse process to the base of the spinous process of the vertebra above. Each long rotator goes to the same point on the next vertebra but one. The rotators are overlaid by this series of more obliquely running strips of muscle, which together form one long muscle, the multifidus muscle. Each segment of the multifidus arises from a transverse process and inserts on the sides of the spinous processes 2 to 4 vertebrae above. The rotators and the multifidus extend the whole length of the spine. Their action is to produce rotation of the upper part of the spine towards the opposite side. These deep rotating muscles are overlaid by much larger muscles. To get a picture of these remaining paravertebral muscles, we'll divide them into a lower group, the long muscles of the lumbar and thoracic regions, and an upper group, the long muscles of the back of the neck. The two groups overlap. We'll look at the lower group first. They're known collectively as the erector spinae muscles. They form a large mass of muscle, extending all the way from the sacrum to the upper part of the thorax. At their origins, they're joined together. Passing upward, they separate out into 3 somewhat distinct muscles, the spinalis, the longissimus thoracis, and the iliocostalis lumborum. The erector spinae muscles arise from this massive common tendon of origin, which is attached to the spinous processes of the lumbar vertebrae, to the back of the sacrum, and to the iliac crest. Spinalis inserts onto the spinous processes of the upper thoracic vertebrae. Longissimus thoracis inserts on the lower 9 ribs and the adjoining transverse processes. Iliocostalis lumborum inserts further out on the lower 6 ribs. The erector spinae muscles are important in keeping the body upright. The action that they have depends on whether they contract on both sides at once or on one side only. When they contract on one side only, they produce lateral flexion of the spine, to one side or the other. When they contract on both sides at once, their action produces extension of the lumbar and thoracic spine, straightening our back as we stand up from a stooping position and keeping it straight as we lean forward. The action of the erector spinae group is counteracted by muscles of the abdominal wall, which we'll see later in this tape. Above the erector spinae muscles and overlapping with them are the long muscles of the back of the neck, which we'll look at just briefly at this point. They're the obliquely running splenius and longissimus muscles, and beneath them the vertically running semispinalis. Here's its upper end.